Hello, my name is Mark Juul. I'm presenting this project that we've been working on in Oakland, California, called DisasterRadio. So the purpose of this project was to try to attempt to create a different kind of mesh network using low bandwidth, off-the-shelf radio transceivers. So I want to talk a bit about why we started working on this. One of the cool things about mesh networks is that they're really high bandwidth. We can use them for internet. They can get really high bandwidth, but you can only get high bandwidth in long range if you go on a rooftop and mount nodes and run wires. And so one of our biggest challenges in our network is that we don't really have the resources to go to all the rooftops that want nodes and installed gear. And it seems like this is the biggest limiting factor for us. So we get lots of these Wi-Fi nodes that are sitting in people's houses, but they're simply not very useful. They're just faking it. So they're little hotspots. They're using the whatever internet people have in their homes. They're sharing a bit of it with the world. That's cool. They're VPNing to connect to the rest of the mesh. But it's not really a mesh, and so very few of the houses end up having real mesh connectivity to each other because they're too far apart. They don't have anything on the rooftops. So we've been trying to figure out what do we do about this, and of course there's the people solution. Just get more volunteers, organize better, get more people to go on rooftops and mount gear, make it easier, make sure we have all the tools. Maybe we should just buy a crane or something to make it simple, but all this stuff is really difficult. So we started thinking about how to solve this rooftop mounting issue using technical solution. So like I talked about, it's not just the installation on the roof, it's also the running of the cable. So often we have people who are renting, and when they hear they have to run a cable, then they say, well, that's going to be problematic because we have to make a hole in my house. That's not good. Sometimes we can use Ethernet over power systems, but then finding an outdoor plug that's on the same line as an indoor plug and making sure the outdoor one is weatherized, it's not that easy either. Okay, so yeah, we talked about, hey, maybe we can lift the drones use drones to lift the nodes onto the roof, and then we don't have to mount. But we still need power, so then maybe we can give them solar power. But the panels that we need are quite large. I calculated that on the shortest day of the year, if it's a cloudy day, if you want to run all the way through the night, you get close to 100 watts. If you get a really low power node, you may be able to deal with something like 50, 60 watts, but it's still hard to do, and especially if you're going to be lifting it onto a rooftop with a drone. And it's expensive. Okay, so what if we could do something different? What if we could have a node that can be deployed on the roof? What would that look like? Can we try to prototype this now? It seems like it's challenging, but maybe we can do something really simple. So what we want in this implementation would be to test this idea. It should be entirely solar powered. We're in California, we have lots of sun. It shouldn't have any cables, it shouldn't have any mounting, or it shouldn't have any cables going outside of its own little box. It shouldn't require any aiming, and it should deliver some amount of bandwidth. And at least one useful application. We should have one thing we can use it for, so it's not just a technical test bed. So maybe we could do something like chat or something simple like this. Okay, so a lot of the houses in our area, a lot of them are flat roofed. So we have this house and we have this person inside, and they want to use this DisasterRadio node that we want to build. So maybe we can make a thing that sits on the roof and talks to the indoor equipment with some semi-directional Wi-Fi thing, and then talks to the other nodes with some other Wi-Fi link that's more omnidirectional, doesn't require any aiming. So one way to achieve this would be to use these really cheap, low bandwidth radios that can send small packets of data. There's a bunch of them on the market. They're cool because they're really long range. They don't require, even without a directional antenna, and they don't use much power. They're pretty affordable, but of course the problems are that they have almost no bandwidth. Packet size is so small for a lot of them you can't even run IPv6 over it. Not even theoretically. The minimum packet size of IPv6 is larger than the maximum packet size of these systems. So they're not really suitable for IP transport. But we could, and they don't have good channel sharing, which is could be a huge issue, because if they don't have a good way of sharing the same channel, then how are we going to, what's going to happen if there's a lot of nodes? We won't get good utilization of bandwidth. So what if we take one of these radios and hook it up to high-gain omnidirectional antenna? And that doesn't really make sense, high-gain and omni, or if you want to have gain, you have to make it more directional. But you can make directional omni antennas that are more like a flat pancake shape, so they don't go much up and much down, but they expand further out. So maybe we can use one of those. Okay, so this is an example of one of these radios. This is one of these so-called LoRa, L-O-R-A radios. And if you've heard about LoRa, you've probably heard about it with regards to Internet of Things. These radios are designed to work in this star topology configuration to report data from sensors. They're supposed to run for a really long time on a small amount of power, like a AA battery or solar panel. And the idea with them is that they run this thing called LoRaWAN, which is basically the layer 2 of the LoRa stack, where they report to a gateway node, and the gateway node is hooked up to the internet, and then the gateway node acts back to them, and they go back to sleep. So they can sleep for most of the time, come online, report a packet, wait for an ACK, and go back to sleep. This is cool. The nodes end up being really cheap. They're transmit and receive capable, and then the gateway nodes in the star topology, they end up being really expensive, like often about $1,000, because they need high gain antennas to pick up the weaker signal from the small nodes, and they need to be able to receive on every channel at once. And they implement a bunch of extra logic. So I looked at one of these and I thought, well, maybe we can use them without the gateway, because they can transmit and receive. And turns out you can just switch off the layer 2, and you can use just the layer 1 of them, and send it, and just decide, I want to use the modulation only from the LoRa protocol stack. And that's really the magic of the LoRa protocol, is the modulation. It's better than FSK for a lot of use cases, because it's much less prone to noise. So if there's a lot of interference, you're in an urban environment, the LoRa protocol uses this modulation scheme called CSS, or chirp spread spectrum. It makes these FM chirps that look like 45-degree angle or 30-degree angle lines going across your waterfall diagram. Anyway, maybe we can use one of these. So this is what the marketing materials say about one of these chips, the RN2903, which is the 915 megahertz US version. They say, some of them say you can do 2 kilometers in dense urban environments. That's from an article on DigiKey. The official materials say you can do more than 3 miles in an urban environment. We haven't really gotten to testing these ranges yet, but I'm hoping to maybe play around with this tomorrow if anyone wants to run around the city with me. I brought 2 nodes that are functional, and I have maybe one more we could put together. Okay, so we need, in order to make a router, we need some other stuff. We need a processor that can run some applications, and in order to talk to the inside of the house, we need Wi-Fi. There's already a solution for this. Everyone knows about the ESP8266, and now it's the newer and better version, the ESP32. Very low cost. I think the ESP8266 is like less than $1.50 right now. You know, they're not very powerful, but they can run small apps, and they probably run the logic that we need. You can get them with a little integrated antenna, but you can also get modules that can use an external antenna. So then we could hook it in. What if we hooked it into like a downward pointing high gain panel? You can get these very like 14 dBi panel antennas that like cover like 120 degree-ish. And then what if we took one of those, pointed it straight down, put it on the roof with all the other hardware, so you can talk to it from inside the building? All right, so then we just need some solar and some battery. There's a lot of different solutions out there. You know, we probably only need like 3 or 4 watts for a unit like this. You can get these 5 or 6 volt panels that are really cheap, that are like 3 to 6 watts. We need some kind of system for for charging and discharging the battery. We want to have a really long life of the battery. So we need something a lot like what Electra presented the other day, but maybe for lower power. There's also an open design available on Adafruit that we've looked at. So we have to figure out which one we want to use. Okay, so we made a first prototype. The first prototype was just made with completely off-the-shelf stuff. It's super inefficient, so we just got one of these little battery, USB batteries that you can use to charge your cell phone. Some of them you can actually charge and discharge at the same time. It's inefficient, but it works. We got a little solar panel that outputs 5 volts that can plug straight into the USB. No soldering involved. We just hooked it all together. Here I have the ESP8266 hooked up to the LoRa chip on a breakout board with a little antenna. And it works. It's not pretty, but it works. So what can we do with it? Well, as I said, we probably can't do IP, but we can create these small Twitter-sized messages, basically. So we have maybe around 160 bytes left over after all the packet headers required if you want some signatures and some encryption involved. And with that, we can probably write some interesting apps. So maybe we can make a chat app, and maybe we can make something like community mapping app. So a really cool feature that we might be able to implement is something like tide pools, community mapping, where every node has a local like vector map, like vector tile map of the local area. So it can serve that up to the user. And then the only thing that needs to be transmitted across the mesh is like, oh, this location needs water, this location has a party going on, or whatever you want to share. This could be very useful in a disaster scenario, but also just having basic chat, secure chat in a, disaster or censorship scenario could be. It's a lot better than nothing, even though it's very little. Okay, so the software for this is we're using NodeMCU firmware for the ESP8266 right now, just to get some rapid prototyping going, so we don't have to write everything in C. Probably port most of that over to C, but it is cool to have a little Lua console that you can play with when you're developing and debugging. So what we have running now is we have integrated DHCP server, DNS server, and web server. So you can connect to this ESP8266. You can go to a website, and it'll serve you up a little chat app. We also implemented a little Telnet Lua console. So one of the limitations of the ESP8266 is that it has only one serial port. And since it has only one serial port, the LoRa chip here actually talks over serial, so that's problematic. So what we did, what you can do is you can switch the serial to some alternate pins while it's running. So when you telnet into the Lua console, it automatically switches the serial from being on your USB debugging interface to being on the pins that you hooked up the LoRa chip, the radio chip to, and then you can still have a debugging interface over telnet. Where am I? Over here. Okay, so version 1, we're implementing flooding only. We haven't quite gotten to testing the flooding yet, but the idea is just that everyone repeats the messages that they hear, and then they keep track of a hash for a while of the last X messages, and then they don't repeat the stuff they've already repeated. Very simple. It'll get us to chat app, but it probably won't scale very well. We've been scheming on routing protocol for the next version. The routing protocol is interesting because it has really, really crazy restrictions on what we can do with it, the system. So I don't think if anyone knows a routing protocol that would be good for this kind of system, I'd love to hear about it. But we're trying to figure out how to make something where you can basically subscribe to feeds, and then everyone, kind of like multicast for IPv6, but really, really simple. So people can say, or a node can say, I'm interested in this feed, and then it'll receive all the packets from that feed. So right now we're basically testing some different hardware. I've been using the RN2903. The reason why I've been using that chip is looking at the specs, you might be fooled into thinking that these are pretty equivalent, these three LoRa chips these are the 3 LoRa chips I've been able to find on the market, that they're pretty equivalent in their specs, but when you look at it, these 3 chips all do both LoRa modulation, CSS modulation, and FSK modulation. And when you look at the first page of the spec sheet, all their specs are actually just for the FSK. And so if you dig into it a little bit, you'll see that for CSS modulation, they can't do nearly as high transmit power. except for the Iron 2903. So according to the spec, it's a lot better, but we haven't tested yet. Okay, so let me just do a quick demo. So the software, we have a couple of issues that we need to resolve with, we have a memory leak going on with the Lua code. We don't have WebSocket support, so we're doing polling from the web app. But let me just quickly demo what we have here. Okay, so I have my debugging console on the little node here, and
excuse me?
Yep.
Can you switch to a larger font size, perhaps? Oh. It's pretty hard to read from here.
Well, I don't know how to do that.
Something like Control and plus? Perhaps?
Yeah, let's try it. Here we go. Okay, great.
Awesome, thanks.
Okay. Cool. So this is what you get from the Node MCU firmware. You just get this Lua console over the USB serial or normal serial if you don't have the USB breakout. What you can do with the Node MCU firmware if you haven't used it is, let me just find the right stuff here. Okay, so we have a bunch of Lua files, and you can basically just run this little upload script. The upload script just runs this Python command, and the README file in our Git repo explains how to set all this up. So you can run the upload script, and you can like tell it what. Just need to disconnect here. What files to upload, and it'll quickly upload. So this makes for really rapid development. You don't have to reflash the entire unit. You can just upload Lua files, and it'll just run the init.lua when it starts up. And then you can connect, and you can restart it, and it'll reload the program. And if you don't get any errors, you're good. Okay, so I'm going to disconnect from that, and I'm going to telnet, or I'm going to connect over Wi-Fi. If I can actually. So here we see it come up as DisasterRadio, and then with its MAC address. I'm just going to wait for it to connect. Okay, so we're connected to it, and we have an IP address. It comes up right now with a static IP. You just telnet in, and then you get a telnet-based debug console. If you go to the same IP on the web browser, it'll load up the web app. It's a little bit slow. We have a module that's a little bit too big that we need to strip out, so the JavaScript is a little big right now. We're using Browserify for the module. Okay, so you get this little chat app, and you can say like, oh, my name is Juul. And then right now I am in debugging mode, so I have to initialize the Lua, or the LoRa. So I'll initialize the LoRa. Oh, let me just try it again. Oh, no, never mind. I got the, here we go, LoRa in it. And it's like, oh, I'm not getting a response from the chip because we have this issue where the chip comes into a weird state. So you have to restart it. And we need to add a little toggle so we can actually do that in software. Okay, so it comes up. Okay, so the chip's connected. It sent all the initialization to set the radio channel and all that shit. And then I can start the LoRa transceive loop here, which just makes it continually receive and transmit if there's anything to transmit. And so you see it getting radio error about every time the receive times out, but that's just because it didn't receive anything. It's not an actual error. And then inside of here, what you can do, I'll just open up the console. So I was going to do a demo with 2 units so we can actually see this going back and forth, but one of my units died. I was trying last minute to solder a new one, but I didn't quite make it in time. So I can't really show the full link, but at least you can see that you can send some data. And then it actually sent this and got a response from the little module, and the module here actually transmitted, got radio GX OK from the chip and transmitted the thing. So we should be able to have a chat. And that's basically what we have at this point, but I feel like we could expand this to include other apps, and maybe we could make something where we could drop these little units that is small enough that it could be easily drone deployed onto a bunch of different rooftops. Ideally, maybe it would be people who signed up for this, but abandoned warehouses are a fair game too, right? So maybe we could cover very big area very quickly if we could make a bunch of these nodes and make them really cheaply. So our goal is to try to get to the point where we can produce maybe like 100 or 200 of these nodes with our custom PCB that has everything on it, including the downward pointing panel antenna. And then the assembly of the only thing the unit will need basically is a decent antenna pointing up, and we have to figure out how to make it not blow away from the rooftop. That's a remaining challenge. But if we could make a few hundred of these nodes, deploy them across the Bay Area, maybe we could actually cover an area, like a sizable portion of the entire Bay Area where we are located, and kind of test this out on a large scale and maybe from there we could try to deploy it in places that have bigger issues with censorship than we currently do in our area. Maybe we could use it if we ever have one of those big earthquakes they keep warning us about. So that's it. Any questions?
Thank you. Hi. So you're running this without a gateway. So it's LoRa without the gateways, right?
Yeah, so it's just a layer 1 of the LoRa, no gateway.
Nice. And you are still using encryption.
Still using a what, sorry?
Encryption, the encryption from LoRa?
Encryption, no, we're not using, we're only using the modulation.
Okay. So
the encryption would happen on the client side in the browser.
Oh, okay, I get it. So you would have the same key on every end, or you would just have it at the application layer?
You generate the key in the JavaScript, and we're looking at using something called Hyperboot, which is a Node.js module that basically bricks the cache the first time you load it. So the first time you load the web app, it just trusts it. It just trusts it and loads it. But then if you access the same app in the future, unless you clear your cache, if you access it in the future, it'll never ask the web server for the JavaScript again. So then you can, as long as you trust that on the first connection, no one will be able to send you false data later. I think that's the best security you can do in a web app like this.
Yeah, nice. And I had another question.
Hi. To me, this project looks very much like wireless personal area networks based on Zigbee, for example. Just on Zigbee or Bluetooth, whatever, just on a larger scale geographically. I saw that you mentioned that IPv6 isn't available due to the small packet size, and I was thinking whether you had looked at protocols or adaptions like IP6 LowPan, for example, which is adapted to these small packet sizes.
We haven't looked at that, but I'd love to talk to you afterwards.
Okay, because there is, maybe for the others it's also interesting, there's actually a lot of protocols building up on that. So you have IPv6 compatibility, and there are also routing protocols available for that, as well as application or transport protocols. So maybe this could be of interest.
Cool. And I should also mention that someone already implemented for the LoRa modulation scheme a GNU radio module. So it might be possible to run like a Raspberry Pi 3 with a RTL SDR to be able to act more like not a gateway, but be able to receive on implementing with changes to the scheme. So we could change the packet size perhaps.
Question from the IRC. Typically, LoRa uses a gateway, listening on 3 channels. All your nodes are all on 1 channel? Question mark.
Yeah. So currently, with this scheme, all the nodes are on the same channel. There's no reason why you couldn't have some nodes that have multiple radios and can relay between different areas of the network that use different channels. It's just adding more radios just adds a little bit of cost, but there's no reason why we couldn't have one node with multiple radios and then increase the bandwidth of the total mesh.
Thanks. Any other questions?
Packet size is 256 bytes.
Sorry, what?
What is the packet size? 256?
256 bytes maximum.
Okay.
Is the flooding already implemented?
Is there, sorry?
The flooding. You showed a slide when you had version 0 with the flooding. Every node is just forwarding, but it receives.
Can you hold the microphone closer?
Yeah, sorry. You have shown a slide in which you had version 0, in which you were planning to flood the network, just having each node repeat what it was receiving.
Yeah.
Is that implemented already?
The flooding is, I wrote the code, but I haven't tested it because I only had 2 nodes with me. So I can't guarantee that it works. But I mean, it's very simple. It just keeps an array of hashes. So then checks the message coming in and then repeats it. We probably would need to test it with a bunch of nodes, and we probably would have to add some kind of like random retransmit delay, so they don't all retransmit at the same time, which probably would happen right now. So I'm not confident that scheme works at all. I ordered a bunch more hardware, so when I get back home, hopefully we can test it with like 10 nodes instead and get some idea. But we also just need to simulate, and we need to set up a simulator. So if anyone knows about simulating low bandwidth mesh networks like this, or could recommend what kind of simulator we should use, that would be cool.
Thank you.
Any other questions? Does one ever see? Do you wanna?
From the IRC, can you extend the range by adding more nodes, or do all nodes have to radio see each other?
Yeah, I mean, with the flooding, it's just every node's just retransmitting, so it's inefficient. But yeah, they will relay, and there's no magic there. But if we want to get to the point where it can scale well, we really need to develop a different kind of routing protocol where everything isn't flooded. And at that point, we'd probably only flood, the routing information. So if anyone wants to help us develop a really low bandwidth mesh routing protocol.
If there are no further questions, let's thank Juul for this interesting talk.